Let us just once more return to the structure of atoms. We already know an atom consists of a nucleus surrounded by electrons, and we're going to focus on the nucleus. That consists of protons and neutrons, and there is something about those protons and neutrons. The protons and neutrons must be present in the right proportions. There may not be too many protons in proportional to the number of protons, or the other way around. And there may not be too many of them together. If our nucleus is too big, something will happen. So, without the right proportions, or too large nucleus, the nucleus will become unstable. Oh dear, what's going to happen then? An unstable nucleus will, at some moment, which we do not know ahead, disintegrate. Decay is another word for that. And when it disintegrates, it will emit radiation. Now, that whole process of an atom being unstable, a nucleus being unstable, decaying or disintegrating, and emitting radiation, that's called radioactivity. This whole phenomenon is called radioactivity. You probably heard about it. Are there many radioactive atoms? Are there many unstable atomic nuclei? Yes, there are. Let's look at this. This is a nucleus card of quite a little while ago. Each square in this poster, this is actually a very much small shown poster. Each square, each colored square, I must say, not the white ones, but the ones with the other colors like black and blue and red and yellow and green. And each square is one known atomic nucleus. And only the black ones are the stable ones. So all the other colors, blue and red and yellow and green, and there's even some orange there I see now, that's all radioactive atoms. So by far the majority of atoms is not stable, is radioactive. So what about radioactivity? Well, we humans cannot manipulate the radioactivity of a nucleus. And what does that mean? We have no influence at all. Have no influence. Sorry for the typo. We cannot have any influence on when the nucleus will disintegrate, or by which process it will decay. And there are 8 different processes of decay. And we cannot choose them. It's all determined by the nucleus itself. So which decay processes are there? Well, let's divide them into 2 groups. The first with process 1, with each problem. Those are nucleus that occur in nature. And the other one, process 2, they're decaying too fast to occur in nature. So we make them in, let's say, particle accelerators or nuclear installations. So what about nuclei that are too large, too many protons and neutrons together? It will decay by alpha radiation. Are there, proportional to the number of protons, too many neutrons present? The decay process will be beta minus. What all these processes mean we'll see in another video. Are there, compared to the number of neutrons, too many protons present? There's actually 2 possible processes in the first group. That's either beta plus or electron capture. So a nucleus will grab an electron. But what if it's not just a little bit too large, or just a little bit too many neutrons, or not just a little bit too many protons? What if the proportion is way off? There are far too many neutrons. Then a nucleus can emit N radiation. It will send out loose neutrons. So on the other hand, if we have a nucleus with far are too many protons, way out of balance, it will emit irradiation. Protons lose protons. And we can even go further. If it's way too large, not just a little bit too large, but much, 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 much too large, then it will decay by spontaneous fission. The atomic nucleus will just fall split into many more larger parts. And maybe you're now just missing a process you heard of. Alpha, beta. How about gamma? You heard of gamma rays? That's also something to do with radioactivity. Well, it's a bit of an exception here, because gamma doesn't actually occur when there's a problem with the composition of the nucleus. It's just that there's too much energy in it, and that is determined by a wrong shape of the nucleus. Then it will emit gamma radiation. So it can happen to a nucleus which is not large, just a small little one. The proportion between neutrons and protons is exactly right, but it is in the wrong shape. And wrong shape means too much energy, and the rearranging of the present neutrons and protons will give gamma radiation. Well, that is all for now about radioactivity.